Today we're going to take a look at this piano sustain pedal. It's not working. It's not giving any change to the keyboard performance when we press on the pedal. I assume there's something wrong with it. I've tried it on a couple of different keyboards and it's just not working. So I'll show you some schematics, but a sustain pedal is basically just a open close contacts. To pull up a schematic for a piano sustain pedal, I suggest just going to Google, searching for piano sustain pedal, switching to images, and it should pull you up multiple versions of schematics for the sustain pedals. And what you'll notice is that all the schematics show you it's just a simple switch closure. It's either apply sustain, don't apply sustain. And some keyboards are expect sustain when open or expect sustain when closed, so normally open, normally closed. But and they often have a switch on them that might change the mode to normally open, normally closed. But you can see, normally open, normally closed. But this one's not performing in either switch mode. So, first things first, let's take a look at this and see if we can figure out what's wrong with it. What we should get, let's just turn on voltometer. You can see when there's, of course, no contact, then it's a open line. Then when it's shorted, we should get a very low resistance. Right now, it's open line. You can see I just have it connected to the two, so we should be able to press the. See, and here's the thing: is kind of what I expected. We're not getting any change in the resistance. It should switch from open to close. So we just switch mode. See, and that's not doing anything either. Let's flip it over. There's just 4 screws on the back here, so let's get these out. Let's see what's going on inside of here. Whoa, you can see the spiders have been living up in there. Hopefully you can see this, but what you see is that there's just a plastic pusher that pushes down against some metal contacts. And I don't know if you can tell that from this angle, but you see a set down in there that are normally closed. The ones closest to us are closed with no pressure. And then when you push down, it opens those. On the other side, at the bottom, might be hard to see, but you see a set that are normally open. And then as you push this down, they close. So we get a different behavior whether you're pushing down or letting off, which switches are open. And then this should switch out which set of contacts are going out to the plug. So clearly we've got a problem in here. It's not making contact in either configuration. So either we've got a wiring problem or the contacts are just so dirty that it's not able to change the resistance. All right, so let me get this cleaned up a little bit and then we'll take it apart to the next step, get that switch out so we can take a look at it. Just took it out and blew off some of the spider webs. Looks like not all of them, but what I want to do is get to this switch so we can take a look at it. All right, here we have the switches. Well, they're pretty simple switches. Not a lot to them. So, but my suspicion is that these contacts are probably so dirty that they're just not making a switch closure. All right, let's get the voltometer and hook it onto these and check these out. All right, what we want to do is check the switches to see if they're closing, and something I'm going to do is I'm going to swap out my normal test leads for a set of grab hook style, which makes it so much easier when working on something like this, when we want to just hook onto the contacts and then fiddle with mechanically with some switches. So we'll take off our standard test leads, and if you don't have a set of these when you're working on electronics like that, they are really nice. You plug these into your voltometer, you can clip these on, they stay there, and then you can fiddle with things mechanically, and it's pretty nice. So we'll just plug these in, turn it on to resistance mode. We'll confirm that our grab hooks are working. Yep, small resistance. Then what we want to do is, what you can see going back down this line, there's basically just two sets of contacts. This wire going all the way down to the plug, there's only two contacts here. So you've got this white wire and this contact right here. So we'll just reach down and contact one of these wires down here and hook onto the other one where they're all connected together here. See, we're just not getting any. Oh, see, now if I fiddle with it, sort of squeeze it mechanically, so they're just under its own spring force, they're just not coming together. So, and you know, it looks like they're contacting, so I'm guessing that they're just dirty in between there, that those contacts have just become oxidized over time, because if I squeeze them and push through the oxidization, it works. Similarly, oh, that's because we've got this side switched in. Then, similarly, we should be able to push this side, but we need to switch the switch to the other direction. Now, if we push the other side, you can see that, oh, even then it's still in the hundreds of ohms. So, it looks like the switch is actually still working. They just almost assuredly have dirty contacts. So let me go get some really fine-grained emery paper, fine-grained sandpaper, you know, something to be able to clean those contacts, and I'll bet we'll be back in business. All right, good. Let me do that. And all right, so what we have here is some 800 grit sandpaper. Happens to be a wet dry sandpaper, but you want something that's a pretty fine grit so that you don't just wear the terminals right off, because they are pretty small. You just want to clean the oxidation off them. So just a fine abrasive is what you want. So we're just going to put this between here and just drag it across the contacts a few times. All right, now let's hook back up and see what we get. So we'll go to the same juncture points. Come on. Turn on the voltmeter. And make sure the switch is switched the correct direction. Nice. So you can see now we're getting a contact. Open line, contact. And that's not with me pushing them or anything. Open line, contact. Sweet. And that 0.02 is pretty much the resistance of the leads themselves. All right, so now what we got to do is we got to do the other side. All right, so similarly, let's hook this up, and you can see those are, so we don't get any change when we do that. Now we need to switch the switch to the other direction so that we're using the other set of contacts. You can see that it's a open line because it's open. That's kind of what you'd expect. And we close it pretty gently. Nothing. There we go. Open line. Low resistance. Open line. Low resistance. All right. I think that's going to fix it. So what we'll do is we'll put it back together, plug it into the keyboard, and see if we have a winner. And now, before we get it all put back together, let's go ahead and test it. What we have is we have open. Oops. Let's see now. Maybe we better check between the contacts and the plug. Oh, maybe we have a break in the wire. Well, there you go. All right, let's take this back apart and check that again. Question is, are we getting contact out of this ground lead? We don't seem to be having contact. Well, I'll be a son of a gun. I think maybe we've got a break in the wire. All right, so it looks like there's a fault in here. So what I'm going to do is, we've got these kinks here, could be here. I'm actually just going to cut this off since I got to repair this anyhow. I'm just going to cut it off. We're going to start fresh, get rid of all this. So we're just going to start with just cutting it off right here. All right, you can see the wire up in there. Not really sure where the failure point is up here, but we'll trim this off. And you can see it's kind of got some corrosion up here on the copper, so I think it won't hurt to get rid of this piece anyhow. Then we'll just start fresh. We'll get this center wire free, so we'll clamp this off and solder it over here. And then we'll take these shield wires, bring them together. And I guess something we probably need to do before we start soldering things and putting them together is make sure there's not a break somewhere else in the wire, possibly even down at the plug. So we'll go ahead and do a continuity test between all of these and the 1/4-inch jacks. Let's just go ahead and get this stripped. Now let's see if there's a problem here. So we've got contact with the shield, and it is open. Oh man, what is going on here? Confirm that we have a good contact. We do. Well, that's kind of a drag. It looks like we have a break somewhere else in this line. Let's just go ahead and cut this off. Strip this back, and we'll strip the wire back, and we'll find out on which end is it. We'll clip onto this side. Take the other end, and let's just see if between here and here we have contact. Well, I'll be a son of a gun, we do. That's actually good news. So we don't have to cut into this and replace this. Now the question is where in the wire is the break? Let's try again. We'll clip to this end of the shield, grab this end of the shield, and now I'll be a son of a gun. There is a break in the wire somewhere, and we just need to replace this piece of wire. So fortunately, we saved enough of this that we can recover the jacks. That's great, and we've bracketed the failure, so the jack appears to be good. We'll be able to reuse that. Somewhere, this cable has a break in it. All right. Well, let's find some new cable. I went and looked around to see just what 2-conductor wire I had handy, and I've got a bunch, but I wanted something that was reasonably flexible. 2 conductors, and there's nothing special about this. Reasonably robust, and you think of extension cord wire. It's used to being handled, and has decent vinyl sheath on it, and relatively inexpensive. Get it in whatever lengths you want, and I happen to have some. So just going to measure off whatever distance we need of this, cut off the ends, solder them onto this connector, bring them up into the foot switch, put them back together, and then we'll see where we're at. I got the plug soldered on and multiple layers of heat shrink to provide a strain relief. I didn't show this on camera because my soldering station's in the other room, and it was easier just to go over there and do that. But I just soldered the wires together to this extension cord, multiple layers of heat shrink to prevent bending stresses. Same thing on this end. I extended the wire and added heat shrink, put it down to this center connector of the switch, put the other line over here, the one we'd marked black for ground. We'll confirm those, but let's go ahead and see if we had any success. So for starters, let's just see if the sleeve is connected properly to these centers. Appears that they are. Good. Let's see if we can get the ring connected. Let's see, I got it all heat shrinked up, protected, so there we go. Yep, it is. Now, let's see if the switch is going to work. All right. Well, we already showed this once, but we'll get this put back together now. All right, again, make sure all the wires are out of the way and going to be out of the way. Make sure nothing's getting flexed or bent. Looks like that the contacts are being made. All right, that looks good. Let's confirm this again. Take these out of the way. Do the same thing we did last time. And all right, now it's working. Okay, now switch the switch, make sure the other direction's working. Closed, then open, closed, then open. Great. Open and closed. Excellent. All right, let's get it put back together and test it out. Feels pretty good. Give it a quick test here on the bench. Then we'll go plug it in and try it. All right, looks like everything's working. Let's try it on the keyboard. All right, what you're seeing here is a Novation SL keyboard. And listen and watch right up here. So when then I hit the sustain and let go, you can hear it carrying. Then I let off. And there we go. Looks like it's working.